All right, welcome to a new unit. We are starting Notes 5. This one I'm actually doing a little bit differently. You're going to see my hand under here writing the notes because I'm actually doing it with paper this time instead of with my finger trying to write on the iPad. That was very sloppy. I'm sorry. Thanks for bearing with me and reading through my handwriting. For this one, we're representing proportional relationships. So let's take a look at what this little sentence says. In 1870, the French writer Jules Verne published 20,000 Leagues Under the Sea, one of the most popular science fiction novels ever written. One definition of a league is a unit of measure equaling 3 miles. I think that's interesting. I didn't really realize that a league was an actual mathematical term, or a unit of measure anyway. So here's what it equals. If 1 league equals 3 miles, then 2 leagues would obviously equal 6 miles. 6 leagues would be 18 miles. And now they flipped it on you. 36 miles would be equal to 12 leagues. And 20,000 for the book 20,000 Leagues Under the Sea would actually be 60,000 miles. All right, let's take a look now at what the relationships are. What do we see in the table? I see that every number in the bottom row is actually 3 times the number in the top row. So let's take a minute to write that. Every number in the bottom row is 3 times the number in the top row. Okay, handwriting didn't get a lot better. Sorry. Okay, now that we have that information, let's go ahead and fill out for each column of the table. Let's fill out part C. For each column of the table, find the ratio of the distance in the miles to the distance in leagues. Write each ratio in simplest form. So what they did, and I really want you guys to pay attention to this, is they flipped it on you. They did 3/1, whereas on our table it was 1 per every 3. Pay careful attention to that. That was not by accident. This is later going to become our x coordinate, and this is our y. And it actually is important that when you're writing it out in a ratio form, you flip it and you actually do put the x on the top, the y on the top and the x on the bottom. And that, like I said, it seems very backwards. You fill out a table just like you always did from when you were younger, but now that you're in basically algebra, you're writing ratios, they're flipping. The x coordinate is going to be your top number. So anytime you're writing a ratio now, we're going to flip it and we're going to take our y and put it over our x. So that'll come back here in a little bit. 3/1 is already as simple as you can get, so we'll just keep it 3/1. Our 6 per 2 would simplify to 3/1. Our 18 per 6 up here in the table is also going to simplify to 3/1. 36 per 12, guess what? 3/1. And then our 60,000 per 20,000, if you divided that out, that would be 3 per every 1. So part D, what did you notice about the ratios? They're all equal to 3/1. Okay, let's look at the next part. Representing proportional relationships with equations. So now we've done it with a table, and now we're going to look at actual equations. The ratio of the distance in miles to the distance in leagues is constant. That means it was 3/1 every single time. It was all the same. It was constant. That means the relationship is said to be proportional. A proportional relationship is a relationship between 2 quantities in which the ratio of one quantity to the other is constant, just like our 3/1 every time. A proportional relationship can be described by an equation in the form y equals kx, where k is the constant of proportionality. I also want you to put a little box around k here. In 7th grade, you guys learned the term k as your constant. In 8th and especially 9th grade, that letter is going to change to an M. I don't want you to confuse it. I will sometimes call it K because that's what you did in 7th grade, but I will sometimes call it M because that's where we're going to end up going. I really wish they wouldn't have done it both ways, but that's how it is, so you guys should just know they mean the same thing. And that is basically, it is your constant. So basically in the other one, it would have been our 3/1. Let's try a problem. Megan earns $12 an hour at her part-time job. Show what the relationship between the amount she earned and the number of hours she worked. Show that it is proportional. Then write an equation, that's new, for the relationship. Make a table relating the amount earned to number of hours. I gotta get rid of this. Okay, there we go. Okay, so first of all, it says this very important information. She earns $12 every hour. So if she worked 1 hour, $12. 2 hours, $24. 3 hours, $36. And 4 hours would be $48. All right, for now, we're going to refer back to this table in just a sec, but for now, go on to the next page so that we can continue this problem. I'm going to kind of move it to the top here so we can still see it. All right, for each number of hours, write the relationship of the amount earned and the number of hours as a ratio in simplest form. First, I want you to notice that we wanted the amount earned on the top of your fraction and the number of hours on the bottom. Let's take a look at this table. Amount earned, if that's the number we want on top, see how it flipped again? And the hours is going to now be on the bottom. So we are, once again, putting our Y on top and our X on bottom, so we're flipping it. So here we go. For 1 hour, it was $12 per 1 hour. Let's make sure we know that that's in simplest form already. For $24 earned, she had worked 2 hours, and that also simplifies to 12/1. For 36 hours worked, $36 earned, she worked 3 hours, and that simplifies to 12/1 also. And then lastly, if she earned $48, she must have worked 4 hours, and that also simplifies to 12/1. So since they are all 12/1s, since they simplify to the same thing, that is showing that it is constant. Since the ratios are all equal, what do we know? That means that the relationship is constant, or we're going to call it proportional. The relationship is proportional. Okay, now let me tell you about writing equations. X is going to represent the number of hours. So remember, that's what we said right up here. X is the number of hours. Y is the amount earned. So Y is going to be the amount earned. Use the ratio of a constant in proportionality. This letter K or M, whatever it is going to be your constant. So that is our constant ratio. So 12/1, 12/1, 12/1, that's the constant. So we're actually going to change K or M, whatever it is, to a number. So Y is equal to the amount earned. So no matter how much money we earned, it's going to be based on how many hours we worked, and how much we get paid is 12/1. Now because you guys are in 8th grade and it's time to understand that 12/1 is also equal to 12, I would rather you write it as Y equals 12x. That to me is the simplest form, and that is how to write an equation. You're always going to start it with Y equals, and whatever that Y is equal to is your constant times your whatever X represents. In this case, it's number of hours worked. All right, now that we've done, we've looked at tables, we've done equations, now let's take a look at graphs. You can also represent proportional relationships with a graph. The graph will be a line that passes through the origin. This is extremely important. This word and this coordinate that I've underlined go together every time. In order for a graph to be called proportional, it is going to touch the origin in the graph at 0, 0 exactly. If it touches somewhere else up the y-axis, it is going to be not proportional. So all of what we're doing today is proportional. They're all going to be a graph that goes through the 0, 0, the origin. Okay, so this is still based on our original table, about 20,000 leagues under the sea. So if we are at 1 league, that means we've gone 3 miles. A lot of people aren't sure how to use the labels on the graphs or why they're that necessary. It is so we can understand fully what these coordinates mean. And they mean that at 1 league, it would come out here at 3 miles. So 2 leagues is 6 miles, 3 leagues is 9 miles, and so on. So these coordinates are not random. They actually represent something in this scenario. Now let's look at an example about the moon and your weight on the moon versus your weight on Earth. All right, using points on this table, let's fill in, using points on this graph, let's fill in this table. All right, our first coordinate looks like it's over 6 and up 1. So the coordinate is 6, 1. What does that represent? It looks like it represents that at 6 Earth pounds, I would only have something that weighed 1 moon pound. So if on Earth it was 6, it would only weigh 1 pound on the moon. The next coordinate it shows is 12, 2. And again, that means something. That means that if it weighed 12 pounds on Earth, it would only weigh 2 pounds on the moon. Okay, our next coordinate is 18, 3. And that means that if it weighed 18 pounds on Earth, it would only weigh 3 pounds on the moon. And then I actually really like how it jumped all the way over here to this last coordinate, 30 and 5. I bet all of you guys were guessing that I would next say something like 24 and 4, which would have been correct. There would have been a point at 24, 4, but you don't have to talk about every single point that's on a line. We just picked out another point that would be on it. We could continue and pick another point that would be way up here, and that would also be proportional too. So instead, we picked out that if on Earth you weighed 30, on the moon then you would weigh 5. All right, the constant, the m or the k or whatever you want to call it, the constant is, remember, it is going to be our y over x. So we're flip-flopping these. So it wants the moon weight per Earth weight. So if moon is on top and then Earth is on bottom, we want to go 1 over 6. So the constant of proportionality is 1/6. Now that we know what that m or k is, depending on what you want to call it, our constant, we can write an equation. Remember, equations are always y equals your constant and then x. So our constant is 1/6 and then x. So y equals 1/6 x. All right, guys, it looks like it's time for the your turn. So take a minute and pause the video and try numbers 1, 2a, and 2b, and see if you can do it on your own, and then check back with me here in a few minutes and see if you got it right. Good luck. All right, so the your turn was not too difficult this time. Basically, check your work. If there were 15 bicycles produced each hour, that is a 15-to-1 ratio, 15 bikes per 1 hour, and therefore our equation would be y equals 15x. So if your constant is every 15 bikes per hour, and I already flipped it, you might notice, every 1 hour was 15 bikes. But if you flip it, because we're always putting our y's over our x's, it would be 15-to-1, which would simplify to y equals 15x. All right, on number 2, the graph shows a relationship between the amount of time that a backpacker hikes and the distance traveled. What does the 0.56 represent? I'm really hopeful that you guys did not write, it means go over 5 on the x-axis and up 6. Of course it means that, but this is an actual scenario about a backpacker. So what does 5, 6 mean? It means, this point specifically means that after 5, read your label, time, hours, so at 5 hours, he had backpacked 6 miles. That's why those labels are on there. So the point is not random. It means that every 6 miles, it takes him 5 hours. So you should have written something like 6 miles were hiked in 5 hours. Okay, and then the very last one, what would that equation be? Remember, I want your y. This is your y-axis. If you forgot, that's your y. This is your x. I want your y value, which was 6 in this case, over your x value, which is 5. So when you write an equation, it's always y equals your constant, which was 6 per 5, and then x. So, and then there's no way to simplify that. 6/5 is just 6/5. You could call it 1 1/5, but I do not want you guys doing that. You'll find out later why it's not good to have a mixed number. I would rather you keep the fraction improper, even if it is improper, just leave it. So 6/5 tells us a lot more than 1 1/5. If I said, how far did you hike in 5 hours? You wouldn't say, well, it was 1 1/5 something. Like that just doesn't make any sense. I'd rather hear 6 miles hiked every 5 hours. So that's why you want to leave it improper.